focused on the ability of AI to automate repetitive jobs and tasks, saves us a lot of time, and that's valuable, but as an economist, I'm more interested in the ability to help human beings make better decisions. And my view is that algorithms don't suffer from decision fatigue. They don't suffer from all these biases. You can train algorithms using millions and billions of data points, and you can train them to help human beings to make the right decisions. And if we can do that, we're going to see transformation across a variety of different verticals: education, law, medicine. All of these things involve lots of decision makings that we as human beings need to make, and we can do better with machines, with algorithms, and with deep learning. What I see are two trends that make me a little concerned. Number one is that we've kind of ignored causal inference. And people may not realize this, but as an economist, the one thing you're trained in really, really well is how to do causal inference, how to ensure that when you're looking at X, you can determine it's truly influencing Y, and it's not being influenced by Y, and they're not both being influenced by something else. What we're mostly interested in here is prediction. If I can predict an outcome, whether someone's going to click the buy button or any number of different metrics, that's what matters the most. And for me, what this constitutes is the why, right? Why does one variable influence another, or does it in the first place? And so I see with these models, as we're moving to machine learning and deep learning, we're losing the why. Well, the way you interact with companies, between companies and customers, it's changing. It might be in person or on the phone. You might interact with a sales associate. It might be via digital channels, websites, apps, so on and so forth. But those are rapidly converging towards chat and messaging. What we find is that the buckets representing chat behavior, effort, friendliness, responsiveness, and emotion, that accounts for about 62% of the outcome. So I'll set the stage here. In the course of working with a large company, about 25 million in annual revenues, they give us 200,000 chats, and they say, hey, what are we doing right and wrong? We fed it in the engine. We reverse engineers best and worst practices, right? We ultimately came back to them and said, we think we understand what makes for good and bad conversations. We're going to feed this information to your agents in real time so that they know the right way to engage. The system doesn't understand cause and effect. It doesn't understand that that person was unhappy initially and they were probably going to have a tough experience. What it saw was that every time you say sorry, this ends up in a bad place. So don't say sorry. If you don't understand the how, and you don't do some more digging, and you just rely on the results of a deep learning framework applied to this data, you would end up with the exact opposite solution as what you're hoping for. Right? So when we apply deep learning, it can unleash the potential to solve countless problems, but we cannot forget about the how and the why, or we run into a lot of big mistakes like the ones I described. Thank you.